All right, let's continue on with example number 3. A right cone has a base radius of 4 meters and a height of 10 meters. Again, if it does not say slant height, it means the perpendicular height. Calculate the surface area of the cone to the nearest square meters. So let's draw a little picture out here. I got myself a cone. I draw a curved surface there and then a dashed surface there. I know that my perpendicular height is right here. This is 10 meters, and I know that my radius is 4 meters. But what I really need is my slant height. So to figure out my slant height, I'm going to use Pythagoras' theorem again. So I'm going to draw out this triangle. I've got my triangle here. This is 10 meters, this is 4 meters, and this is my slant height. So again, I can use this modified form. Height squared plus radius squared is equal to my slant height squared. So I do 10 squared plus 4 squared is equal to s squared. 10 squared is 100, 4 squared is 16, so this is 116. It's equal to s squared. I square root both sides. And the square and the square root cancel out, and I get s is equal to the square root of 116. 10.8 meters. All right, once I've got that figured out, surface area is equal to pi r squared, that's the base shape, plus pi rs. So now I fill in my formulas. Pi, nope, that's pi, not 4. The 4 comes next. Pi times 4 squared plus pi times 4 times 10.8. Now I'm going to do something a little bit strange. And in Foundations and Pre-Cal 10, you should be able to understand this. If you don't understand it, that's okay. You should be able to type this straight into Desmos exactly like that, and it will tell you the answer. But I'm going to do this. 4 squared is 16, so I have 16 pi's here. And 4 times 10.8 is equal to 43.2. These two multiplied together is 43.2 pi's. Now 16 pi's plus 43.2 pi's is equal to 59.2 pi's. And this would be meters squared. This could be an answer. But your more likely answer that you want is you're going to do 59.2 times pi. And you get 186 square meters. Again, if you just type this straight into Desmos like this, it will tell you your answer. I write my math exactly how Desmos reads it. So it should be easy for you to just put pi times 4 squared plus pi times 4 times 10.8 into Desmos. Remember, this was the lateral area. This was the base area. All right, so again, step 1, write down your formula, fill in your variables, compute the answer, make sure you have the proper units and you're rounded to the proper amount if it tells you. Last example. A model of the Great Pyramid of Giza is constructed for a museum display. The surface area of the triangular faces is 3,000 square inches. The side length of the base is 50 inches. Determine the height of the model to 1/10 of an inch. Now this does not give us quite enough information. We don't know if this is a rectangular. Well, I guess since it only gives us one dimension, we assume that this is square-based. Okay, so let's give it a sketch. Here's my slanted 3D square. It's 50 inches by 50 inches. I put a peak above that. Draw those out, put a dashed line to the back. And what we're trying to figure out is we are trying to figure out this height here. And what we know is we know the triangular faces is equal to 3,000 square inches. So here's what we know to start. We know that if we take 4 triangles, 4 times the area of the triangles is equal to 3,000. Right? All 4 of these triangular faces are the same. And all 4 of them add up to 3,000. So 4 times the area of one triangle is equal to 3,000. So the area of one triangle will be equal to, well, we divide this side by 4 to cancel these out. We divide this side by 4. What's 3,000 divided by 4? I should know this. 750 inches square. So one triangle is 750 inches squared. Right? So 750 for this triangle here, 750 for the one in the back, 750 for the one on the side, 750 for the one on the front. Now let's look at one triangle. We can figure out the slant height now. Let's take one triangle. We know that the base is equal to 50. And the slant height, we don't know. But we do know that the area of this triangle is equal to 750 square inches. So let's look at our formula for the area of a triangle. It's equal to base times the height divided by 2. There are 3 variables in this formula. If we know 2 of them, we can find the third. Well, we know the area, we know the base. So we should be able to find that. That's going to give us our slant height. I'm going to replace this h with our slant height. So I know that 750 is equal to 50 times my slant height divided by 2. Now I have to be able to solve this equation. I times this side by 2. I'm going to times this side by 2. These are going to cancel out. I'm going to get 1,500 is equal to 50 times my slant height. So 50 times what gives me 1,500? Divide both sides by 50. Divide by 50. And I get my slant height is equal to, cross that out, 150 divided by 5 is 30. All right, so this is 30 inches. But that's not what the question's asking us for. The question's asking us for the height. So now I know, you can do this in black. This is equal to 30 inches. I also know that this is 25 inches. So now I have to use Pythagoras' theorem to determine my height. So I'm going to write out my Pythagoras theorem. My height squared plus my radius squared, this is my radius right here, is 25, is equal to my slant height squared. Well, I don't know my height. My radius is 25. I have to square that. is equal to 30 squared. All right, so let's focus on this. 25 squared is equal to 625. 30 squared is equal to 900. Now I'm adding right here. I'm adding 625. So to do the opposite, I have to take away 625 from both sides. So what is 900 take away 625? $275. Now my last step is to get rid of my square by square rooting it. And I will get my height of 16.6 inches. That's a pretty complicated problem. You have to work everything backwards. In Foundations and Pre-Cal 10 Math, you have to be able to work everything forwards and backwards. And that's all for the examples.